Somewhere near you right now, there's a piece of iron in your keys, in the frame of your bed, bolted into the walls around you. You've probably never thought about where it came from. Why would you? It's just metal, ordinary, everywhere. Even the ground beneath your feet doesn't escape it. The very center of the earth, the core spinning far beneath every continent, is mostly the same nickel-iron alloy found in meteorites. You are standing, right now, on top of a planet-sized lump of the exact material this story is about. But the true story of how humans first got their hands on iron is far stranger than ordinary. It starts in space. It ends in a mistake nobody meant to make. For most of human history, iron wasn't common at all. It was rarer than gold. Rarer than almost anything a human hand had ever touched. Because for thousands of years, the only iron on Earth's surface that people could actually use didn't come from the ground. It fell from the sky. Iron meteorites form inside the molten cores of asteroids, crushed together under pressure for millions of years before a collision sends fragments hurtling toward Earth. When one of those fragments survives the fall and lands somewhere a human happens to find it, what's left behind is a dense, dark lump of metal unlike any rock nearby. Cut one open, and under the right treatment, you'll find something no earthly rock has ever produced. Long crossing bands of crystal, grown from millions of years of impossibly slow cooling deep inside an asteroid's core. No furnace on Earth, ancient or modern, can recreate that kind of patience. It only happens out there. Around 3200 BCE, in a cemetery at Gerza, roughly 70 kilometers south of modern Cairo, someone was buried with 9 small tube-shaped beads, strung alongside gold and lapis lazuli. For over a century, nobody knew what those beads were actually made of. Then in 2013, a research team led by Diane Johnson at the Open University, working with Joyce Tildesley at the University of Manchester, scanned the corroded beads using electron microscopy and X-ray imaging instead of cutting them open. What they found rewrote the timeline of Egyptian metalworking. The beads weren't smelted from ore at all. They were hammered flat from meteoritic iron, then carefully rolled into tubes, thousands of years before Egypt ever learned to smelt iron on its own. Someone in the 4th millennium BCE found a rock from space and turned it into jewelry. Would you have recognized a meteorite for what it was, 5,000 years before anyone knew what an asteroid even was? Notice what that burial actually tells you. The beads weren't strung next to scrap. They were strung next to gold and lapis lazuli, materials already treated as precious, in a grave built before Egypt was even a single, unified kingdom. Iron wasn't a tool yet. It was treasure, ranked alongside the rarest materials people had access to. And it stayed that way for a strange, long time. Real evidence of Egyptians smelting iron from ordinary ore doesn't show up until roughly the 6th century BCE, nearly 3,000 years after that Gerza burial. For most of ancient Egyptian history, sky iron wasn't a stepping stone towards smelted iron at all. It was simply rare, prestigious, and completely separate from anything happening in a furnace. Ancient people had their own explanation, and it wasn't scientific. It didn't need to be. When something falls out of an empty sky, heavier than any stone nearby, and hammers into an edge sharper than anything a person has ever shaped by hand, the mind reaches for an explanation big enough to match the object. Researchers who study how humans process the unexplained have long pointed out the same basic reflex. When evidence runs out, the brain doesn't sit comfortably in uncertainty. It fills the gap with meaning. Naming this metal heaven wasn't so different from what your own mind still does whenever something feels bigger than the explanation you've got for it. In Sumer, they called this metal anbar, fire from heaven. The Hittites used kuon, the exact same meaning. In Egypt, it was bia and pet, a thunderbolt from heaven. Cultures that never met, never traded, and spoke entirely unrelated languages all reached the same conclusion independently. This metal did not belong to the earth. It belonged to the sky. And in a very literal sense, they weren't wrong. The most famous piece of sky iron in the ancient world stayed hidden for more than 3,000 years, wrapped inside the bandages of a teenage king. When Howard Carter opened the tomb of Tutankhamun in 1922, he found a dagger resting against the mummy's thigh. Gold handle, rock crystal pommel, a blade that had barely rusted after 32 centuries underground. For decades, Egyptologists argued over where that blade had come from. Then, in 2016, physicist Daniela Comelli led a team that scanned the dagger with a handheld X-ray fluorescence device, without cutting into the artifact at all. The blade's composition was unmistakable. Iron mixed with almost 11% nickel and a trace of cobalt. That ratio doesn't occur naturally in terrestrial iron ore. It's a signature almost exclusive to meteorites. A king who ruled 33 centuries ago carried a weapon forged from a rock that fell out of the sky, generations before anyone on Earth figured out how to make iron on purpose. So the first age of iron wasn't an age of mining. It was an age of scavenging, waiting for the sky to hand over what the ground couldn't provide. Eventually, that changed. And almost certainly, nobody meant for it to. Here's the obstacle Bronze Age metalworkers were up against. Copper melts at around 1,085 degrees Celsius. With enough charcoal and a steady flow of air through a clay furnace, ancient smiths could reach that temperature and pour liquid copper straight into a mold. Iron is a different problem entirely. Iron doesn't fully melt until it passes 1,500 degrees Celsius. No Bronze Age furnace on the planet could get anywhere close to that. So if nobody could melt iron, how did anyone ever end up making it on purpose? The answer is that, at first, they didn't need to melt it completely. They just needed to get unlucky in a very specific way. Picture a Bronze Age copper smelter somewhere in Anatolia or the Near East. A squat shaft of clay and stone packed with layers of charcoal and crushed ore, bellows pumping air through narrow clay nozzles to keep the fire hot enough to work. Copper ore never comes out of the ground pure. It's tangled together with other minerals. And one of the most common contaminants is iron oxide, the same reddish rock that rusts today. Smiths had already learned a trick. Adding iron-rich rock to a copper smelt helped the unwanted minerals melt into a separate layer of waste called slag, which could be skimmed off the top, leaving cleaner copper underneath. They weren't trying to make iron, they were trying to get rid of it, which is exactly why the accident makes so much sense. Every so often, under just the right combination of heat and airflow, somewhere around 1100 degrees Celsius, hot enough to soften, but nowhere near hot enough to melt, the iron oxide wouldn't fully turn into slag. Instead, some of it reduced down into a spongy, half-solid lump sitting in the ashes at the bottom of the furnace. Not liquid, not melted. A crumbling, gray, mostly iron mass mixed with soot and impurities, sitting in a fire that was never built to produce it. Archaeologists call this a bloom. Would you have recognized value in a lump like that? Pulled from the ruins of a furnace, meant to make something else entirely? Most smiths probably didn't, at least not at first. Plenty of early blooms were likely discarded, or thrown back into the furnace as scrap. The Czech archaeometallurgist Radomír Pliner spent decades excavating and analyzing early bloomery sites across Europe and the Near East, and his research shows just how much slag and how many failed furnace runs it took before iron production became remotely reliable. It wasn't a single flash of insight. It was hundreds of years of accidental byproducts, repeated across countless furnaces from Anatolia to the Caucasus, before someone finally noticed that the strange lump left behind could be hammered into shape. Hammered while hot, reheated, hammered again. Each cycle squeezed a little more slag and soot out of the spongy bloom, packing the remaining iron tighter, denser, more solid than it had been the time before. And somewhere in that repetition, someone noticed it held an edge differently than bronze did. None of this looked impressive. There was no dramatic pour of glowing liquid into a mold, the kind of scene you might picture when you imagine ancient metalworking. Just soot-covered hands, folding and refolding a dull gray lump for hours, on the slim chance that this batch might finally turn out usable. That unglamorous discovery, a byproduct nobody was looking for, is the real origin point of the Iron Age, not a genius inventor, not a divine gift from the heavens this time, just a mistake that someone chose to pick up instead of throwing away. Here's the part that surprises most people. For a long time after that, iron still wasn't better than bronze. Early smelted iron was riddled with impurities, brittle in unpredictable places, inconsistent from one batch to the next, depending on the ore, the fuel, and pure luck. Bronze, meanwhile, was a known quantity, dependable in a blade or a plow. So if iron wasn't actually better, why did it eventually take over the ancient world? Circumstance forced the issue. Bronze requires tin, and workable tin deposits were rare, clustered in only a handful of locations across the ancient world, from Central Asia to the edges of Europe. Entire kingdoms depended on long-distance trade routes stretching thousands of kilometers just to keep tin flowing in. Around 1200 BCE, that entire system collapsed, almost all at once. Major powers that had dominated the region for centuries, the Hittite Empire among them, crumbled within a generation. Egyptian temple inscriptions from the period describe waves of unfamiliar raiders arriving by land and sea. A loosely connected group historians still refer to only as the Sea Peoples, their true origins never fully settled. Historians still debate how much of the collapse came from invasion versus drought, famine, and internal revolt happening all at once. What's not in doubt is the outcome. Trade routes broke down across the entire eastern Mediterranean, and with them, the flow of tin. An event historians now call the Late Bronze Age collapse turned a reliable material into a luxury almost nobody could still afford. Within a century or two of that collapse, sites scattered from Cyprus to the southern Levant show a sharp, unmistakable jump in the number of iron tools being produced. Not because anyone suddenly perfected the process, because everyone who used to rely on bronze no longer had a choice. Thilo Rehren, an archaeometallurgist who has spent his career studying this exact transition, has pointed out that the shift toward iron wasn't really in doubt once the underlying logic became clear. Unlike tin, iron ore was nearly everywhere. You didn't need an empire's trade network to find it. You needed dirt with the right reddish tint and the patience to keep failing at your furnace until something finally worked. Smiths who had spent generations quietly experimenting with unreliable, brittle iron suddenly had no other option. Necessity accomplished what curiosity alone never had. It forced an entire civilization to master something that used to be considered a mistake. And they did master it, slowly, through more accidents layered on top of the first one. Somewhere in that long process, Smiths began noticing something else. Iron left buried in hot charcoal longer than usual, then hammered and cooled quickly, came out of the fire harder, sharper, far less likely to bend under pressure. They had no word for what was actually happening, no concept of atoms or carbon or crystal structure. But without understanding any of it, they were letting carbon from the burning charcoal seep into the surface of the iron, slowly transforming soft iron into something closer to steel. It would take another few thousand years, and a great deal of chemistry nobody in the Bronze Age had access to, before anyone could explain why it worked. Another accident, one that got repeated on purpose the moment someone realized it worked. That is the pattern running through the entire early history of iron, start to finish. Nobody designed it. Nobody woke up one morning intending to invent the metal that would eventually frame your buildings, run through your car, and sit quietly inside the device you're using right now. Centuries later, once smiths across the ancient world had finally tamed the process, iron did what bronze never could. It armed larger populations at a fraction of the cost, because the raw material no longer depended on a fragile trade network stretching across half the known world. Empires that rose after the Bronze Age collapse didn't just happen to use more iron. In a very real sense, some of them were only possible because of it. It was found in the sky first, then dug out of failure, then sharpened by 1,000 small mistakes that somebody happened to be curious enough to repeat. You'll find that same pattern almost everywhere you look in human history, once you start noticing it. A mold contaminating a petri dish became the discovery of the first true antibiotic. Overripe grain left too long in water became the first fermented beer. Progress, again and again, has looked less like a plan and more like someone refusing to walk away from a mistake. Your own brain runs on roughly the same principle. Most of what you've ever gotten good at, whether you noticed it happening or not, probably started as something you almost dismissed before you realized it actually worked. It even echoes something older than human choice altogether. Evolution runs on the exact same logic, minus the curiosity. Random mutations appear, with no plan behind them, most useless, some actively harmful. But every so often, under the right pressure, one accidental change turns out to help an organism survive long enough to pass it on. Nothing about that process is designed either. It's filtered, generation after generation, the same way 1,000 failed furnace runs eventually filtered down into a technology that reshaped the world. Humans didn't invent that pattern. They just started noticing it and using it, faster than anything else on the planet ever had. So the next time you're holding your keys, or a knife, or gripping the steel frame of the chair underneath you, think about where that material actually came from. None of it was inevitable. None of it started with a plan. It started with someone standing over a ruined furnace, staring down at a lump of scrap they were supposed to throw away, and asking one question instead of walking off. What if this isn't trash? That ordinary piece of metal near you right now was never ordinary at all. It's the answer to a question a Bronze Age smith almost didn't bother asking.